afternoon. I'm so happy to see you all. So we're going to guess what our topic is by a poem that we'll read to you from this book, The Grapes of Math. And Lauren is going to read it, and I'll walk around with the actual hard copy. Okay. Take it away.
So, it's a picnic. The ants all scream. How many ants are in this scene? Try to count them one by one. Before you finish, they'll be done. Find a square before you count. Soon you'll see the right amount.
So, how is this helpful? What do you think this is about? If you
Does
look at
anyone
this
see the
picture.
square?
Yes.
You see the square?
Yeah.
How do you know it's a
How
square?
do you know it's a square?
How many raise your hand? Jill.
There's an equal number of ants on all the sides of
Right.
the square.
Good. So 1, 2, 3, 4, 1, 2, 3, 4.
Yes.
Great. So they're insinuating in the poem that you'll count the number of ants faster if you can see the square visually first. Now raise your hand if you know what topic we're doing. Raise your hand.
And
You were right.
Yeah. Geometry.
Geometry. Very good. Very good. Okay. Oh, yeah, you got it.
Okay, so we're also doing second grade geometry, but we are focusing on the attributes of shapes.
That's the main.
Should we introduce ourselves? Sophia, Josa, Lauren.
Okay.
So, when teaching geometry in the elementary school, you should consider the following: a brief history of geometrical reasoning, the State Common Core learning standards for mathematics, Van Hill's levels of geometric thinking, rich geometry lessons, as well as including literacy, and also using manipulatives such as tangrams that promote visual and tactile learning experiences that enhance conceptual knowledge.
Which usually comes before procedural knowledge. Okay, so this is our history part. What? Geometry is a branch of mathematics that explores the properties, measurements, and relationships of lines, points, and solids. The word geometry derives from the Greek words geo and met, meaning earth and measuring. It's pretty much just the fundamentals. This is getting down to it. Okay, 2000 BC to 1600 BC, the Babylonians began constructing geometrical thinking as they needed to make measurements for crops, farmland, when trading, and learning how to construction and learning. Basically, they needed it for their agricultural needs. At this time, Babylonians became familiar with the general rules of finding the area of rectangles and triangles, and they also knew how to find the radius of a circle. Ancient Egyptians invented measurement formulas to compute land areas and crop volumes, similar to the Babylonians, and they also figured out, like in the last presentation we talked about it, that the area of any triangle is half the product of the base times the height, and they could calculate the volume of pyramids. So by looking at the pyramids, they would see the angle, and they'd take the height, they'd look at the base, and it's interesting, the story of seeing the shadow. And this is just an ancient Babylonian fragment of a mathematical tablet using triangles inside a square to deduce surface area. And we can't forget about Euclid. So around 300 BC, the Greeks obviously always get into history somehow. And so they, of course, came in majorly later. And Euclid observed the world and the celestial bodies around him and used works of other astronomers to make sense of the universe in his really famous work called The Elements. He simplified our cosmos by making consistent rules for lines, points, and planes, which is later kind of debated, and proofs are made which is kind of against that, which is non-Euclidean geometry. But because this is second grade, and kind of like to think about these basics. All right.
Okay, so the Common Core standards. In second grade, students should be able to reason with shapes and their attributes by recognizing just basic shapes, drawing shapes with specified attributes, certain number of angles, sides, or faces, nothing too complicated. Identifying triangles, quadrilaterals, pentagons, hexagons, and cubes. Three-dimensional type shapes that are much more complex. When comparing shapes, students measure sizes directly or visually, so they're not necessarily measuring the exact size. It's more just like visual, feeling it, like using their senses and stuff.
Yeah.
So.
Van Heel levels. So in 1959, Pierre Van Heel and Dina Van Heel, I think they were married, not sure, developed a theory on how children's geometric reasoning develops. This theory has influenced the curriculum that we see today in schools. There are 5 sequential levels when learning geometry, meaning that students start at one specific level and then work their way up to the next level, and if they can't understand that one level, then they can't move on to the next one.
It's kind of like
So-
Piaget.
Yeah,
A little bit.
and it's not age dependent, so everyone starts at level 0 and works their way up. For this side, though, we started from level 1 to level 5. It varies. So level 1 is visualization, and students can name and recognize shapes by their appearance. However, they cannot identify or articulate properties of these shapes. Usually in like 1st or 2nd grade, most students are on this level, and as a teacher, you want to work their way up to level 2, which is descriptive and analytic reasoning. Students begin to describe geometric shapes and properties by using appropriate vocabulary words. So they start recognizing properties for certain shapes. And then level 3 is making inferences about geometric properties, and they begin to understand abstract concepts, and they're able to recognize relationships between shapes. And then it works their way up to level 4, which is high school and making and constructing proofs, and then level 5, which is more at the college level, and it's looking at like geometric systems. It gets more complicated. Yeah.
Okay, so what's interesting also, because we'll move on, so in 2nd grade, usually it's between level 1 and level 2. Oh, the marker's right there. Which means that they can say, oh, that's a square because it looks like a square to them, but they can't, if you say, why is it a square, they'll say, I don't know. They might not be able to say, it's because it has all equal sides, 4 vertices. They might not say vertices. So then they move to this descriptive analytic reasoning, which is when they start to use appropriate vocabulary words. Okay, so this is just really short. Developing an eye for geometry. 2nd graders need to develop their skills of observation and description. They should practice using property words to explain phenomena in their environments. So I need a volunteer. Jamie. Okay, you're not coming up. So just pick, okay, we're kind of playing a little I Spy. Pick something in this room. Don't make it too obvious. Don't look at Jamie so you see where he's looking. You know how to cheat in that game. So find something, and without saying what the object is used for, just use describing words about what you see, and then we'll try to guess what it is that you're looking at.
I see
Too much away.
a
Clear.
cylinder.
Ooh. A clear cylinder.
Kind of clear. It's a little foggy.
What do you think it is, Kristen?
Is it actually mug?
It's actually small. Great. Okay. So I guess we can do one more. Does anybody else want to go? Does anybody else want to go? Jill?
I see a black rectangle.
What else?
A black.
So you know it's a rectangle. This is assuming that you know the shapes.
Yes.
If you know the shapes, then you can say cylinder, rectangle. But pretend, okay, we'll do this one, and then I want to do just a little variation. Okay, any black rectangle, anything else about it?
Yeah.
Oh, it's a book? Okay, now somebody go find something, but instead of saying the name of a shape, pretend you don't know the name of the
label it.
shape.
Just try to describe, like if it's a square, don't say square. Just
Say,
the sides are
4
equal.
lines.